Okay, welcome to week 2 of the KinFX course. In this week, we're going to start exploring creating a more in-depth skeleton by hand for our organic character. I'm going to be using this cyborg model that we will point to a free download for. And you can use whatever character you see fit if you have a different character you want to use, or if you want to use this cyborg and follow along exactly with me. You can use that download link we will provide. So first here I've loaded up the FBX model, and we can see that our character is extremely large. He's 200 and almost 200 meters tall. This is probably because of it was maybe made in Maya, probably made in Maya, and there's that transform offset of units that we get. To fix that, I'm just going to put it at 0.01 transform, and we'll start to see it at a more reasonable size here, almost 2 meters tall. That's more realistic for a human character. Now that we have our correct size of our character, I'm going to export it as a BGO for future use. So we're going to use a ROP geometry output, and we're just going to direct it where to save. First we'll save our file real quick. I'll be right back. So we have our scene saved now, and we will just export this geometry as a BGO, and we'll call it cyborg. Perfect. We'll save it to disk. Awesome. Now we have our BGO with a proper size for him, and we no longer need our FBX loaded in here since we won't be using it anymore. So let's get that BGO loaded in here. There we go. There's our cyborg model that we'll be using from here on out. And we can start to give it some material if we want to see how it's broken down, how the character's broken down. So let's kind of explore that real quick. We'll put down, first we'll put down a material network, just so we can start to give it a similar color that we can see in our download page. And we can put down a material here, and we'll view it. And when we start to look into the group section, we can see that our geometry is broken down nicely into kind of groups. We have the body, the inside, the low, and the wires. So let's start to let's make a test material here that we can easily distinguish, starting to see those differences in colors, and we'll just make it red or a blue. And we'll call it blue. Perfect. And let's point to there real quick. Get our blue. So our character is now completely blue. Let's see what our different sections are. So our body is this metal plating on the outside, these thin pieces that coat our cyborg. It's kind of like armor plating. It's organic structure. And let's see if we do the inside. Our inside can't easily be seen. We could see that it's actually clipping with another mesh there. We get that Z fighting. So let's see what it's fighting with. My guess is it's the low res. Yeah. So that inside and low are some duplicate meshes that were imported. So we could go in and delete one of them to clean up the mesh. But we have that inside kind of under the wires. And if we check out what the wires are, we can see that they're the kind of stringy things that go under the armor plating but above the inside mesh there. So real quick, I'm just going to create two other materials, and these will be the materials you can use to render your character in the end. This is exactly how we have it set up in our demo scene. Black, and we'll take like a chrome here. So our chrome is going to be like a gray. Perfect. And our black is going to be just black. And we can edit these properties once we apply them to our materials real quick. So let's add 2 others. We're going to have 3 main materials. Our first one is going to be the wires, and we can just use our black for that. There we go, black wires. Our next one is going to be that body, and we're going to want the chrome for our body. There we go. And the last one is going to be the inside and the low res. And I want to make my robot blue, so he's more of a quote good guy looking cyborg, but you can decide very easily on what kind of mood you want your robot to have. In the download page, he has a red inside, which makes him feel just more kind of evil to me. So I like the blue. Feel free to texture your character obviously however you want to. Adjust your roughness and materials however is need be for your personal preference. So now we can see our character with some texture on him, and we can more clearly see what he's like. We will, analyzing this mesh, can, as we broke down the mesh for its materials, can see that there's a lot of kind of detail and difficulty. And if you've done character work before, character weighting, character capture, character rigging, you might be starting to think that this character won't be easily skinned if we just went straight for it. If we just tried to build a skeleton and skin it all by hand, that it would get kind of complicated or annoying because we have these thin pieces of mesh that have this edge to them and no inside. And we also have these wires, which are thin pieces of mesh that go along over our inside mesh. So we just have a lot of layered mesh here that's all supposed to follow one skeleton. So just going at it in a traditional sense of just trying to skin weight it, you might be thinking, if you've done character work before, that that might be kind of difficult, and we would have some good risk of clipping meshes. But we'll further explore how we can solve that issue when we cross it. For now, we'll focus on creating the skeleton for this character. So I'm going to put down a skeleton node because I'm going to build this skeleton by hand for this character. And I'll put our character mesh on template mode just so we can see a nice outline. And we'll revisit our previously discussed skeleton node. So as we covered in the first week, we have several ways of creating our joints. We could do view-based, freehand, and surface. You can play around with normal based as well, but those are kind of the 3 versions that I've used mostly when playing with the skeleton node. We can create and modify our skeleton, and we can, when we're modifying it, tweak where our skeletons are, or even just edit parents without affecting the children. And of course we can name our skeleton as we go along. And of course with the skeleton node we also have our rig tree window that we can open up. For the skeleton, I'm going to start just with a simple point in 0, 0. To make sure it's at 0, 0, I'll pull up the P menu and make sure it's at our origin. And I'm going to call this root. You can structure your skeleton however you see fit. If you've done character rigging before, especially in Maya, You may have some sort of structure of a skeleton that you like to follow along with. This is the structure I use in my character rigs. I have a root at 0, 0 so that if it's cinematics, we can place our character on a ground plane and control everything from this root and easily get our character in position for the starting shot. Or if it's if we're animating for a game, we can easily give our root to our team as the kind of ground plane position, and anytime we want our character to move along with the ground plane or to move up and down if they're jumping or whatever, we can just move this root and it'll move the whole character how we need to for whatever system we have in our games. Further up, we're going to then create a cog, and I'm going to look at it from the side view for this. And instead of view based, I'm going to turn it to freehand. When we turn it to freehand and we're looking at it from an orthographic view, such as the side view, front view, or top view, our joints that we create will snap to that plane that we're looking at. So we're looking at the ZY plane. All of our joints will be placed on the ZY plane, which means it'll place exactly in the middle of our character, since our character is built in the 0, 0 space. He's perfectly mirrored on the ZY plane. So I'm going to create a cog, our center of gravity, which can be up here kind of near his hips. However you choose to build your structure, once again, is up to you. Some people don't make a difference between the center of gravity and the hips. It's the same thing for them. I like to separate out the hips and the spine to be able to operate separately, and I don't like to give skin weight data to the cog. So I'm going to come up here and just click where I feel his center of gravity is, which is, I don't know, maybe here-ish, and we'll call that cog. Then we have a choice to continue up the spine or down the legs, however you see fit. I'm going to continue up the spine since we're on that side view and we are in the middle of our character. There's a few ways we can do it, since we are just creating geometry here and we can edit this geometry later. If we wanted to have a completely even breakdown of this skeleton, of this spine, if we wanted completely even segments and we didn't mind it being in a straight line, we could just build a joint there called spine top or whatever, and later down our chain we could resample just this primitive to break it down into points that we need to, and then give those points transform attributes that we needed to have and name attributes with a rig doctor or with bops or even with Vex. I'll do a sort of similar system to what I just described to set up some twist joints in the arms when we get to there. But I'm just going to construct the spine by hand so that it follows the curve of our character a bit. And I'll just give it about 3 or 4 segments, maybe, just like that. Yeah. And generally, when we think about skin deformation, if you've done character work before, or if you're thinking that skeletons in the digital space should kind of mimic that of skeletons of the real world, we won't get quite the same logic. If we build the spine right along the spine of our character where it should be, then we'll get some interesting skin deformation as we rotate our character, and it won't rotate the way that either our animators are expecting or the way that we're expecting as we set up this character. Now I forgot one of my joints here. I've kind of used the cog as just a starting spine, but I like to have my own singular spine to break up the hips and the pelvis. Hips and the spine and the pelvis. Which, of course, you don't have to. You can build it, once again, however you want to build your skeleton. But I like to have this starting spine just here like that. And then we can reconstruct the parent system using the skeleton saw pretty easily. And if ever we're thinking, I kind of messed up on this placement of either the cog or these spine points, we can just come in, turn on modify mode, and adjust how we need to. And of course, while we're in modify mode as well, we can rename these joints as we start them. So I'm going to call this one spine 0 and spine 1, spine 2, spine 3, and spine 4. Perfect. Not to beat a dead horse, but once again, if you have a different naming convention that you prefer for your character pipeline, feel free to use that. It doesn't really affect things. The only time that renaming a joint will affect things, as we saw in week 1, is if we set up a system in the future and then go back and rename a joint, like our constraint joint that we were working with. We have to rename all those name attributes. Or if you have it set up so that you can grab the names procedurally or through a system, then you don't have to worry about your names anymore. So we have our spine now, and I'm just going to continue up the neck. I'm going to go back into create mode. I'm actually going to move this spine 4 to be more of the center of the neck. So we're in that center of body kind of deformation that I was talking about. We don't necessarily want to follow exactly how a regular skeleton would work. We kind of want to be in the middle so that when our skin weight data is applied, it gets applied to both sides of our body kind of evenly. We can see a similar deformation as we are maybe expecting from our rigs. I'm going to build just a simple, maybe just 2. Our spine 4 actually might be better as a named of a neck base, since our spine 3 will be affecting more of where this primitive is, and our neck base, when we rotate it, it'll be affecting things down the chain more, which will be more of the neck and the head than our actual body. So we have a neck base. I'm going to make a neck mid and call that neck mid. And then I will create a point kind of where the skull and the neck meet, where we want that head to rotate, and I'll just put it about there. And I'm going to create a another joint that's at the top of his head for orientation purposes, for when we come in and orient our joints later, and we'll just call that head tip. Now, a cool thing about KinFX that we didn't quite explore in week 1 is if we discover that our joints are placed not where we want them to for rotation, due to the procedural nature of Houdini, even if we've applied skin weight data or capture weight data to our skeleton, we can always come back up the chain and edit where our joints are, and they will maintain that skin weight data but update their rotation position or their orientation or whatever it is before the skin weight data. Unlike in Maya, we would have to unbind the skin, reorient our joints or reposition our joints, and then rebind the skin and re-edit the skin weights, or find some other workaround where we copy the skin weights back in or save out the skin weights. We can simply come back up the chain later, and I did this a lot when I was setting up the ships, and I'm sure we will get into that in week 7 when setting up, or week 5 when setting up the vehicle. We can see that editing of orientation joints even after skin weight data has been applied, and we might even see it as we come through and set up elbows and arms and stuff later in this video. So we have our head set up now. Now it's time to come back down the body. We have our, I'm going to create a pelvis real quick, actually, just while we're in this viewpoint and it's nice and in the middle. Can make a hips joint there, pelvis joint, whatever you want to call it. And now we can start to make our legs and arms. To do our legs and arms, I'm going to come to a front view, or even maybe stay in the side view. But for this, I'm going to turn back on view-based. We might not get super accurate placements of our hips because we can see here that his pelvic floor will affect how our hip placement is, and the way that our mesh is set up as well. We can see that there's 2 layers of mesh here. Our placement might get placed in between those 2 layers depending on how the computation of the cast works. And we also have this hand in the way, so it might not be super perfect. So feel free to play around with if you want to set up a free hand, which might be a more traditional way of setting up our joints. We can put it right here in the middle of our kind of rump and name it hip L, or L hip. And then we can view it from the front, pull up our P menu, and we can start to move it in world space to our X positive, however much we want to. There we go. And of course you can drag it as well, but since I had it in the kind of ZY plane where I wanted it, I was just going to drag it with the X to be more accurate. And then from here we can go back into view mode, of course, view-based projection, and we can place it down, place down a knee joint. I may have just messed up the hip placement, or the pelvic placement. We'll put that back to 0. Perfect. We'll put down a knee joint here at his kind of in between those 2 creases. L knee. And we'll do an ankle here. And his ball. Let's call that L ankle before we forget. And the ball of his foot right there, and we'll do his toes. We'll go into modify mode real quick just to name the ball of his foot and his toes. Alright, let's look at it from the front. And we have this odd view-based projection, and I accidentally built off of the pelvis, so we'll fix that real quick. Okay, so let's fix our leg structure here. So our view-based placements ended up interpreting our joints to be positioned more along our right leg than our left leg. So let's just turn it back over to freehand. And first let's fix our structure. So our hip goes to our knee. And then we can come back over to modify. And we want our tweak mode enabled. Can come in and place it at the knee. We'll make sure it's positioned well on our right side. And I'm realizing now that our interpretation aligned more with the right leg because of our clipping plane of our side view here. We can see that our left leg actually isn't in view, and once we move that left knee onto our left side, we can't really quite catch it. We can't see it because of how our clipping is interpreting that. So to fix or adjust our clipping plane, we can click D on our viewport here. We can see that we're view type from right, which is what we need to. And we can switch our clipping to either clip plane and then adjust how far away our clip plane is with these parameters. Sometimes it doesn't get us quite what we need to when we're looking at the right side. So we can just adjust our skeleton from any of the other viewports here. Putting our ankle into our center of our ankle again, and we can, if we want to drag our toes with our balls, we can turn off the child compensate and take things as such. Take them together. Now sometimes we want our joints completely in line with one another, especially for something like the foot joint. So we can come when we're in our modify mode and check out our local transform space, and we don't want it to be any different in our X from our ankle, so we can try and take that completely away. And it is based off of the rotation of our ankle, so if we turn on our joint axes, we can see that the kind of X-axis is in line now, but it's kind of an odd thing to be adjusting. So we can just make sure that our, if we need to, we can even just make sure the world space is the same and copy and paste that over. And then when we view from the front, it is a straight line up, and we're in the exact same kind of good position. And these orientations for these joints don't look great right now because they were built kind of at an angle, if we recall. But we'll fix that in a minute when we've done building our skeleton. Doesn't have to be perfect, but if you do want it to be perfect, this is how I would approach it, if need be. Yeah, that's looking pretty good. Our knee joint is pretty good as well, I think. Maybe it can come up a little further to be more in between this crease and where our kneecap is. Yeah. And then our hip joint, as we can see here, we might run into a small amount of problems with our leg joints when we go into solving for kinematics, and this is because we see that these 3 points could be forming 2 different kinds of triangles, right? We can see a triangle ever so slightly as it bends to the right on this front viewport, and then to the left again. We can imagine a triangle connecting from this point to this point to this point, and we have that triangle there that's more pointing instead of straight forward, kind of off to the side here. And that's okay. we'll just need to keep that in mind when creating our orientation points, or we can adjust our skeleton to be as close as we can to kind of a straight line down. As we can see here, you can just readjust some joints to try and get it in a better position. We can actually look at this from the left side instead, if we want to. So we can see our joints better. Could have put our pelvis back more towards the center. Perfect. Sometimes when we get to this is more of a comment as well, as I'm just creating this skeleton, commenting on it in terms of thinking about how we're going to skin weight it. I like to sometimes not have any weight on our pelvis, since if you kind of think about how those muscles down here in this pelvic region kind of operate, our posterior is mostly controlled by our hip sockets and our hip joints, and our kind of abdominals and these muscles in the front and on our back, our flexors on our back, are obviously controlled by more of our spine, and our pelvis is more of just a connection point for all of these muscles that are controlled by all of our other skeleton, all of our other bones. The pelvis is just nice to have because if we want to, say, pop up the right hip while simultaneously popping down the left hip, kind of like if we were to, or even if we were to rotate our hips forward and back, kind of like a twerk, to pop the butt out more, we can just use the pelvis joint to control our hip joints together to pop them out, which is why I like to have the pelvis joint. And our cog, our center of gravity, helps us position our whole character based on its weight. Usually the cog can help us position the upper body, while the leg IKs control where the feet are, so we can make our character kind of crouch in space or move its whole body while it's separate from the IKs, which is why the cog is an important joint. So out of these three joints up here, I sometimes only give weight to our spine and of course our hips to explain why I'm putting joints where they are. And since there isn't a difference in KinFX between our control points, our control handles or our controls, and our joints, since we can just split off our controls, it's even more valid to create this pelvis joint because we can just pull it out later, maintain our hierarchy, and control where our hips are. So I'm getting pretty happy with where things are at. It's looking pretty good. I think we can start to move on to the arms. Perfect. I'm just going to do it from the front view because we can see our arm very clearly here and be able to control it nicely. Nice placements anyways. So let's jump back into our skeleton node. Now we're going to go back into create mode and we're going to middle click on our spine 3. I'm going to build off of our spine 3 because it's our last main joint chain in our spine. That's before our neck. If we were to parent it under the neck, that means whenever we rotate the neck forward, we'd be rotating our shoulders and whatnot, and that doesn't make much sense. So we're going to build it off of our spine chain, our kind of chest area. Typically when approaching a arm, we have something called the kind of clavicle joint, and I'm going to move from freehand to view-based and see how well this does. we have a kind of clavicle joint that will allow us to move the whole shoulder region, including the traps on the back and how our clavicle on the front is oriented. You can think of it as kind of moving that whole shoulder plate region of our arm. This whole section, this triangle of mass, will be controlled by this clavicle or trapezius joint, whatever you want to call it. I've typically called it a clavicle, and I think the rig that that this mesh uses, it also calls it a clavicle, which is LE at the end there. Now I noticed when building this skeleton the first time around that having a shoulder here in the middle of this mass made some sense, especially made sense when approaching this triangle, this straight line for our arm bending, but that the rotation point and how the muscles, quote, of this cyborg are kind of made is that the shoulder rotation point is more of a position in this region. This is where that shoulder socket would be, kind of, more than being rotating around this point, especially since this whole mass, this whole metal deltoid would be controlled, is, you know, part of that shoulder bone. And if we were to look at a shoulder bone in real life, if we were just to pull up a shoulder, we can kind of see, let's find a good picture here. We can see that the socket is inward from our kind of mass of this muscle, and there's a disconnect of how we would build this in digital space and in real space, in real life. To kind of solve that, since these muscles are so exaggerated on this this character, I just decided to build a two-chain structure up here for the shoulder. So we have our clavicle leading to what I would call the kind of shoulder socket. If we go into modify mode, this can be the I keep dragging our joints whenever I click on them, just because there's that slight click and drag. There's this left shoulder kind of socket, and we have this left shoulder that's kind of a more traditional placement for digital skeletons. We have our left elbow and our left wrist. So to break down why I have these two joint chains again is similar to what I was hinting at earlier with our hips and how that triangle pointed off into space at an angle rather than straight forward, is that our triangle here, specifically built for our kinematics, as we discussed in the first week and as we will approach for the second week. We can also see here that that view-based placement did place the joints in between those layered meshes, so it did an okay job, but was based on that raycast from one mesh to the next, and it just happened to be because we have that layered mesh, it didn't get placed quite well, but we'll fix that. So this triangle is important for when we're positioning the wrist, that we bend at the elbow and we kind of meet towards the shoulder. If we were to build our kind of triangle from this socket position, it would oddly affect our twist joints especially, that are in a straight line. We'd have this weird gap of, if we can even just see it right here. We have this weird angle that's created if we were to go that way. It doesn't look quite right with how the straight of our bones in our arm actually are. So we can create this just little hook that our shoulder bone makes anyways. And that's kind of how I would construct how I did and how I would construct the arm for this particular character. Once again, feel free to construct the skeleton however you see fit, or whatever aligns more with your thought process. And feel free to adjust as you go along as well. Now let's dive into the hand. Okay, I took a quick break from recording there for a second and went ahead and fixed our shoulder and arm that we had that had been placed kind of on the surface due to the nature of this mesh. So I want you to go ahead and go through that as well and fix any sort of joint placements that have gone wrong up to this point. You should have the skills properly. Just go into modify mode and you can adjust freehand, or from view perspective, freehand is the most flexible, and you can position things from your different orthographic views and get everything into place how you would traditionally in another DCC. But let's continue with the hands here. I'm going to go back into create mode and into view based mode. And I'm going to just start putting down our joints here for our hand. And notice through this whole process, I've really only been building joints on the left side of our character, their left side, because I'm going to mirror our bones over to our right side in the future, just like we would with other softwares. We want to make sure our bones are nice and symmetrical. So I like to, with my hands, just make some metacarpals joints about at the start of our palm area. If you feel your hand bones or look at your hand when you flex, we see these long tendons that fall along with our bones all the way from our just past our wrist, where our wrist bends, down to our knuckles. So that's where I've placed the start, and then we'll go all the way down to our knuckle as well. And our view based isn't doing super well right now, which is fine. We can always go back through and place things again later. We'll just continue to do it as best we can. Some of them get better, some of them not so much. Yeah, we can go back through here and fix that just with modify and freehand. Oh, I'm realizing I was maybe placing in freehand, and that might have been why our joints were kind of off. I also like to make a little end joint, which I will do here in a second, when creating fingers and toes, that allows us some better orientation later in our process. We can use this tip joint as a means of orienting the rest of our joints. But kineffects, as we will dive into in a second when we get to orienting our bones, also allows us to not necessarily need these tip joints. So we'll build a few fingers, maybe just the the thumb without a tip joint to explore that area. So I'm just going to continue through and build the rest of the hand, and you can follow along or just cut through to where you need to go next. So as I position these finger joints, I'm kind of looking at the way I know where these knuckles are is based on the subdivisions of our mesh. We can see that there's, if we look at this wireframe here, we see that there's an increase in subdivisions at certain points along the finger, and that there's also a bend in the finger usually at those points as well. I'm also trying to keep the joints centered in the middle of the finger, kind of similar to how we wanted our spine for future deformation to be in the center of our body. We kind of want our finger bones to be in the center of our finger. I'm also trying to keep in mind as I build these bones that it's for orientation purposes down the line. It's easier to orient the bones if there's a slight bend from one primitive to another. So the pinky is a good example right there. There's a slight bend. Having straight lines makes it difficult to orient the joints later down the line. And just to see those knuckles, we can tab back over to the viewed mesh and see that there's those increased amount of mesh in these areas where the knuckles are. And that's what I'm going off of. Perfect. I'm just going to dive into the thumb now, and we'll set it up the way that I was talking about before, where we don't use a tip joint for demonstrating with orienting bones later. Our orient joints SOP. So similar to our fingers, our thumb has a rotation point kind of near the wrist if you move around your thumb, and it's not a metacarpal, one of the two, because our thumb only has 3 spans of bones as opposed to our fingers, which have the bone that's in our palm and our 3 spans along our typical finger. So we're only going to build 3 joints for this bone, as opposed to our 5 for our other fingers. And we're going to position those properly as well, real quick. Just to be in the center again. Perfect. That looks pretty good. Now I'm going to quickly go through and name all these bones. I'm going to name them simply by... Oops, I just reparented that bone. That's not what I wanted. I'm going to name these guys at the base the metatarsals, or metas, so I'll call this L, meta, or even maybe L index meta. So I know that's the index finger and it's the metacarpal bone. And we'll go in here and we'll just name this L index base, I like to call it. And we'll call this one L index mid. And this one can be our L index tip. And this one can be our L index end, the very end of our chain for the index. I'm going to go through and rename the rest of my fingers according to this naming convention, and we will then discuss some orientation options for our bones here. Okay, I've gone through and named all of the joints for our hand here. L index, L middle, L ring finger, and our L pinky. If this is your first time rigging a character, it's very important that when we're naming our joints that we denote which side it's on in the name. It's important for our nodes later down in the pipeline for like mirroring, and it's just good for readability's sake when we start creating controls based off of these joints. We can start to understand where they are innately by their name, or our animators can understand where the controls are by their names. Alright, so let's talk about orienting our joints here, because if we look at all these joint axes, some of them are okay. Primarily this spine is decent because we created it one after another, and it's not too bad. Almost all of our Z negative axis are pointed down at the next bone. But it starts to break up when we start to reposition things like our neck joint. We can see that our Z-axis points kind of here, but our neck is over here. We can also see some really confused orientations in the shoulder. The Z-axis doesn't know what to do with our shoulder socket joint, and same kind of goes for positions like our wrist. That's a terrible orientation for our wrist. So let's dive into a new node, and we'll move away from the skeleton node for now, since our skeleton, in terms of hand creating all our joints that we need, is pretty much done. You can of course add your own joints if you see fit for other joints. We'll get into adding some twist bones in our arms and legs. I'll probably just explore it with the lower arm, and you can apply the technique to all other aspects of your skeleton if you desire. The reason, and what are twist bones, in case we don't know what twist bones are. Twist bones are a bunch of joints in between usually the wrist and the elbow. If you look at your own hand right now and you just put it in front of your face with your palm facing away from you, and you flip the palm to face you, you'll notice that your whole arm twists because of our the two arm bones in our lower section of our arm in between our elbow and our wrist. They kind of rotate around each other. We aren't creating that rotation system in the digital space. So in order to compensate for that, we create a bunch of smaller segments in between our wrist and our elbow that progressively rotates less as we go up from the wrist. So our twist bones won't rotate much near the elbow when we rotate our wrist, but closer to our wrist they will rotate more to follow with that wrist, and it creates in the skin deformation of our mesh a similar visual aspect of things. And we'll dive into that further when we get into creating those twist bones, but we're not at least the technique that I'm going to show doesn't use the skeleton node, so we're going to move away from that for now. In fact, we're going to move away from using the skeleton node until we start building a new skeleton for our vehicle. And the reason I'm going to move away from using the skeleton node to create any more joints is at this point it becomes not so procedural if we want to edit our joints later on the line. And by that I mean if ever we start editing our joint chain, doing our orient joints nodes with this node that we'll dive into, if we do some orientations or editing of positions back with our skeleton or any other sort of edits, and then we pipe that into a skeleton node to edit things with the skeleton, we can no longer edit up the chain of this skeleton node. We're cut off. Any chains we do up here won't be affecting anything we do to this chain and downwards. As we can see here, and as we discussed in the first week, when we input something into the skeleton node, it's just a copy of that skeleton we created at that point. So it cuts off our upstream work, and I don't particularly like doing that, but it is something that you can do yourself if you don't mind doing that, or if you have specific use cases that you run into. For now, let's talk about orienting our joints. So we've put down this orient joints node, and we can see that its default parameters have Z pointing down the chain, and pointing down the chain, that means our Z positive axis, Z plus 1, will do its best to point parent joints to their children joints. For things like the wrist, it can get somewhat confusing. It won't point directly at any of our joints, but kind of a nice-ish midpoint. And for things like our pelvis, we really don't like it just applying a 1 stamp over for it, because it makes no sense for our pelvis to be tilted pointing towards our hip like that. So we can come in and start to break out, and especially like this spine 3, our chest area. We don't want that to be at a midpoint between our neck and our clavicle. We just want it to point straight up the back. So applying one orientation to our whole skeleton is not super advised. And we'll also notice that even if the z-axis is pointing down the chain properly with the default settings, we don't really have a good up vector. Our joints are twisted at an angle. We can see that in this ball joint, or even with this ankle joint. We have the y-axis kind of pointing off to the side here, and the x-axis also pointing down. Nothing is pointing directly out backwards or up forwards. So we'll want to explore orienting our joints further. We can do this in several ways. We can create groups within our orient joint node itself, or we can use a group joints node and create some groups ourselves, and then input them into later nodes down the line, like our orient joints nodes or any other use cases for our groups later. So if you see needing a group of joints multiple times over than just orienting joints, we can come in and we can create it. So let's just call this the I don't know, we can call this the left leg. And we can come in and select the joints we need. Now it'll pop up a rig tree, so we can either select things in the rig tree like such. Just by clicking on one and holding shift, we can select a whole hierarchy of things. But we'll notice if we hit enter while our mouse is over on the rig tree, nothing happens. And if we press enter when our mouse is over our node network, it kind of just exits out. And the reason for that is the rig tree selections only work if we have our mouse over our viewports. If we press enter when our mouse is over the viewport, we'll see our section fills in. So that's something important to note. I don't know really why Houdini is programmed that way. It just is. We can also interactively select things in the viewport if that's easier as well. And then of course, when we do that, we want to make sure we hit enter in the viewport. So we have our left leg. We call this group joints left leg. And then we can use that in our orient joints group. So our orient group is going to be our left leg. And we can see that all of our other joints, except for our left leg, have turned white. And our left leg is the only selected group to be orienting right now. We can see that that spine 3 is no longer affected. And we can just control what we're orienting on our left leg here. So that's one way to create groups for orienting. And like I said, if you see use going down the line and needing joints later on, groups of joints later on, then it's probably a good idea to just create all the groups that you need to going forward. Or if you don't see the need for many things beyond creating just the orientations, we can of course select the joints by hand in those orient joints node, just like we would with the groups joints selections. So for now, I'm just going to use the group that we already created and then probably just select things with the orient joints node instead of having a big long list of group nodes, just so we can get things grouped together. So we'll orient joints left leg here. And I'm going to want to use an up vector so that we can get our x-axes or y-axes pointed in the same direction. So if we enable an up vector, we can see that even just by enabling that with the default y positive 1, that all of our x positives have now pointed forward towards the front end of the body. Whereas when it was disabled, we can see that the hip is pointing forward, but the knee is pointing back, and the ankle is pointed to the side for some reason. So just enabling that up vector really helps the orientation a lot by default. I don't mind this orientation. People may have different preferences. But with this orientation right now, if we were to put this into a rig pose, right? When we select the hip, in order to rotate front to back, like the leg is swinging, we're rotating around the Y axis here, which isn't a bad thing. I just prefer it to be the x-axis. So instead of having it be y positive, I'm going to have it be x positive. And now we can see when we pose with our rig doctor, we're rotating around the x-axis to go swinging forward like so. And when we bend our knee, it's the x-axis. And our y-axis is kind of like a not really used axis when positioning a leg not too much. Anyways, the hip definitely can come out like this, but it's not used as the primary axis. Perfect. So that's how I'm going to orient the hip. I like it like that, and the whole leg as such. That's good. Now let's explore how our tip joint here, our L-toe, is oriented properly, whereas in most DCCs, this toe joint wouldn't have been oriented at all. It would have just kept its initial orientation. Well, that's thanks to this one specific parameter over here in our orient joints node, the use parent to orient leaf joints. So a leaf joint is any joint that's right at the end of our chain here. It's alone, it doesn't have a branch after it, basically, this primitive here. If we were to turn that off, we can see that, yeah, our toe joint isn't oriented, and it goes back to how we would expect other DCs to operate. So that's how this parameter is how we're going to orient our thumb when we get to our thumb. And it'll, the calculation it's doing, basically, is it's referencing the parent node to orient our joint. It's taking the same orientation that our parent has and just applying it to our leaf joint here. So if our ball joint happened to be our leaf node, we'd see the z-axis continue to point down into the ground, and we can see that if we were to just put down a delete joints real quick here before orienting, and we take away our toe, and then we take a look at our orient, we can see that that same rotation, that same orientation from our ankle is applied to our left ball of our foot. So that's how the orient leaf joints operates, and it's very helpful for those tip joints. It means that if we didn't want to have all these end joints for our fingers, we wouldn't need to. But I like to still have them for specific models like this one because of this bend in the fingers. If we were just referencing our parent joint, we might get some situations like how our ball pointed into the ground, and that's not the best orientation for that joint. We want it flush with the ground so that when we rotate around the ball of the foot, especially in IK modes, it moves flush with the ground. We're picking up the toe from the ground rather than somewhere halfway through the ground. So that's why I still add some tip joints to things like the fingers, just because this model has a slight bend in those fingers, and I want to be able to capture that orientation, that slight bend, when we're orienting those joints, and it doesn't just continue straight past so it's like orienting towards the fingernail instead. I want it to orient towards the center of the finger. So I'm going to continue through using the orient joints nodes and selecting them in our groups. Real quick before I just start going off on my own, and I hope you follow along and you can go off on your own as well. Let's explore the target joints, or the target groups. So let's create a new one here. And say we have a selection like our pelvis here. We can see that our pelvis, with our default parameters on this node, is orienting towards the hip. As I explained earlier, that's not super advantageous to us because we don't want the hip, or the pelvis, to be favoring one hip or the other. We want it to be flat, similar to the cog, where the cog also is currently not oriented how I want to, and I'll go through and orient that in a second. But we want our pelvis to have one of its planes flush with the YZ plane, so that there isn't a preference leaning from hip to hip. We don't want to give our character scoliosis, basically. So to fix this, we can input a target group if we want to. By default, it'll look at children joints, but if we don't want it to look at a child joint, we can input our own joint. Like the cog. Okay. So we put our cog in as our target groups, but we can see that our orientation hasn't really changed, and it was because I was mistaken for a moment on how the target groups works. Our target groups is really useful for when we have something like our cog joint that points towards multiple bones, that has several chains of children. So by default, if we had no target groups, we can see that the orientation does its best to point in between all of our chains. We could see that with our wrist as well, when we had initially applied our orientation to the whole skeleton. If we want the orientation to point towards a specific child or down chain, we can choose that with the target skeletons. We can see now that we've selected the pelvis as the target group, our z-axis is pointed exactly towards our pelvis. And if we were to change that to be our spine, we can see it adjusts to point towards the spine instead. Joints that can use the target groups as well, the ones with multiple children, can also use themselves as their own target. And when we do so, we get some kind of interesting results. We can see when we don't have a up vector determined and we're not orienting towards parent leaves, we get a slight change in how the orientation is computing. And if we were to start using our parent leaves, it's doing its best to grab the root and also orient based on our own inputs here. So we want it to be pointing down the chain of Z positive. We're taking that parent of our root and we're now continuing Z positive up in that direction. And it happens to rotate as best it can because we didn't determine an up vector for that as well. And we can see that applying an up vector can affect our orientation as well. So play around with joints that can use target groups and see how different settings affect them. For now, I'm going to change this to be a point where I can have the x pointing forward, the x-axis pointing forward, and the z-axis pointing up. Or even try to orient things so that they're in line with the root, so that y is up, and we can control. So it's very similar when we're controlling the cog. If we want our character's cog to go up, we just add y positive, just like world space. And there we go. It's similar. X is forward, or we can have z forward even. Let's try z forward. So we have z pointing back, and we'll just make that a negative. And now our orientation is in line with our world space. Perfect. I want to explore one more thing before I go off on my own and finish the skeleton and leave you to finish your own skeleton as well. Which is the use of multiple axes as we go down the chain. So let's orient our index finger next. And we'll take our index finger joints and our metacarpal, and we will start to orient these guys. The default orientation isn't too bad. I'm going to make sure I enable that up vector. And when I do so, we can see it becomes kind of not great for a finger. We want generally one axis to be in line with how the main rotation of our joint chain works. So right now, if we were to pose this finger and try to curl it along its regular chain, just curling the finger in like we were grasping something, we'd have to do a combination of X and Y rotations, and that's just nasty. We don't want to do that. So we're going to try and get it so we can just rotate one chain, just like we did with our leg here. We can rotate the X chain and it'll bend, as we can see if we take our leg joints here and we just rotate along the X, the whole leg bends how we want it to along its main chain, forward and backwards like that. So we're going to try and orient our finger that way as well. I like to have a joint kind of pointing out from our knuckles, or sorry, an axis pointing out from our knuckles. And to do so, we can fiddle with our up vector, turning it on and off, seeing how that operates. We can see that turning it off, we get this weird twist of axes as it goes down the chain, but turning it on, we get a consistent orientation at the very least of our joints going down the chain. So we can mess around with our up vector by adding values to the two other axes than just the one axis we would typically input. So we can change the point value of the X input, and at a point, once we get to values of 1 or higher, we get diminishing return on our rotation here. We can see that in between 0 and 1 we have very noticeable rotation, but past the value of 1 it gets harder and harder to rotate the axis, because the vector that's created between our inputs here can only go so far with the inputs that we're giving it. So we can mess around with just changing these values around to be an orientation that we like. maybe it's Z led as that. So we can see that our X is really close to being pointing out of our knuckle. So let's just rotate these axes a little bit more and see what leads us to get what we need. I actually have made a huge mistake in putting our Z axis as our main chain and our up vector as Z as well, which means we're not going to get any rotation. So we can't use the same axes as our reference vector as we do our up vector. So we can try a -1 with our Y, and then we can start to see where rotating or adding values to our X gets us. And at this point, we're getting pretty close to an orientation that I quite like. We can just have -1 and -1 in our X and Y's, and we can see that that X-axis is pointed out of our knuckles pretty well. You can try and orient all of your fingers at once if you'd like to. I like to orient them individually. It's not too hard to create a new node for each of them, and especially with this model where we have this kind of nice curve to this hand as our hand normally does. Our rotation for all of our fingers is going to be slightly different. We want them to curl towards the palm. If we were to make them the exact same, we'd have a nice rotation, but they might kind of curl in as if they were very robotic, like just like a robot, which I suppose this is a cyborg, so that might not be a problem. But it will look very symmetrical in how the fingers rotate when curling them all in towards the hand. If you look at your own hand just holding it out straight, you can see that the knuckles, if you were to imagine a line, like a normal pointing out from each of your knuckles, it curves along your curved hand a bit, which is why I like to orient all of the fingers separately. So go through, orient the rest of your skeleton, and I will meet you in the next lesson. I wanted to do a really quick tip video for pesky joints like this pelvis here, where we're on the center axis. We want things oriented to the center, yet we can't find a way for it to stop pointing at our mirror side or created side. If we get to that point, we can always use other nodes presented to Houdini or KinFX. We can use the parent node, the parent joints node, and we can simply unparent our left hip here, and then when we go into orienting our pelvis, we can see that we can now control what it's oriented to using the leaf or not the leaf, and then changing its axis from there, and simply building in a new parent node after it to reconstruct that hierarchy.